Hello friends, I welcome all of you to my YouTube channel Grow by Growing Others. So friends, today I'm going to discuss a very important algorithm on searching from the data structures. And today we will basically see and understand what is linear search versus what is binary search. So we will understand the algorithm, then we will understand the basically we'll start writing the code for the same. So here you see like I have a list of numbers where I have a number in sorted order like 12, 15, 17, 19, 21 and until like 67, and then I've got another number 2 which is something I have to search in this list. So one approach that is very common in linear approach is like what you need to do, you just like go one by one and check in this list, like you just iterate over this numbers list, and then you check each element, and if you find match with 21, then you will be return that number. So basically return that index. So you have to find and return the index of the matching element from this list. So this is more like a force approach where you are gonna get like compare all the elements from the list. If you're lucky, if you get that number initially, then I think you can get it right away. But if it is in the last, then you have to iterate through all the elements. Then you will be reaching to last. For example, 21. I am putting somewhere here after 67. Then you have to go through all the elements. So this is like a brute force approach where you have to iterate through each element, and then we have to basically find that number. So this is about linear search, and then we'll further talk about binary search. So to reduce the limitations that we have in linear search, guys, we have like another approach, another algorithm given, which is called binary search. And binary search is something that does not go one element at a time, like it doesn't go through all the elements. And what it does is like, for example, like first thing that is required as a prerequisite to work with a binary search is like the list that we are working with should be sorted. Like for example, this is a sorted one, but in case the list that we have got, if it is not sorted, then first we have to sort it in ascending order. So you can see like we have a 12, 15, and then increasing order up to and last element is 67. So if it is a binary search, then what is done, what is the algorithm behind binary search is like you have sorted list, then what you need to do here is like if you, so you know the, like you have got also the number to find in this list, right? So you do one thing, simple, very simple. So first, like what we will do, we will take the length of this, like we will take left and right index, and left we will basically start with 0, and right we will start with like length of this list, numbers list minus 1. So basically, if you know, right, like we iterate loop, it starts with 0 and goes length minus 1. If we are starting with 1, then we have to go until the length, complete length. Since it's starting with 0, we have to go till minus. So this is, I can call it left index and right index. So when I say index, like 12 is placed at 0th index, then 15 at first index, 17 at second index, 19 at third index, likewise. So you see like left index, I mean slicing with 0, right index is what? So left index like is here, the 12, 0th element. And right is the last one, extreme last. And then we have to get the mid index. How we will get mid index? Mid index you can get like you just sum up left index like this, and then plus right index, and then you just divide with 2 like this, divide with 2. So guys, you will get like, for example, total we have 3, 3, 6, 8. We have 8, right? So if you, when you divide, you will get 4. And what is the fourth element? Fourth element is 0, 1, 2, 3. Okay. So fourth element is what? Fourth element is this one. So you got index 4, and fourth element is what? 19. 0, 1. So it starts with 0. 0, 1, 2, 3. Okay. So in this case, like since we are saying length is 8, we are saying minus 1. So the length will be 7. 7 divided by 2 will be 3.3.5, right? Like But there is one thing that you have to note down here is like if you are in Python, so for example, let me explain it further. For example, this is 0, this is 0, and this is 7. And if you're dividing with 2 like this, then you're gonna get 3.5, the exact number in decimal. But you just do floor, I mean, just do like this, then this is gonna return complete number, either 4 or either 3. So this is not going to return us number in the decimal, even after like it will give the round off. So you will get 3. So in this case, we're gonna get 3. So what is the third element? So if you start from here, 0, 1, 2, 3. So you got 3, right? Third element is, so mid number to find is, so mid index you got 3. And now if you say mid number, so what you will get as a mid number? Mid number you will get, so here number list and mid index. Mid index is 3, so you will get 19. So you are now at 19. Now you have to check what is your number. Your number is 21. So you are very, very sure 21 is greater than 19. So in that case, now you do not need to search this side, right? You can ignore all the elements before 19. You have to just start searching from 19 to this side, like right side. So you are saving time here, right? Like you are completely ignoring this part, left part, and just going ahead with right part. So we got the mid index. Now we compare with our element. Our element is higher than the mid element, then we can proceed at the right side, not the left side, right? If it would have been lower than, less than the mid number, then we would have gone left side. So this is how the algorithm is. So further when you go, you have to update your right index. So for example, this is your mid index, and if for example we had to search 17, right? So in that case, what you would have done, your left index will be still 0, but your right index will be mid minus 1. Mid minus 1 meaning 19. So now you have to search between this and this. So you have to keep doing this process until unless your left index should be less than equal to right index. So let's go and write the code for it. So let me copy these two numbers. We'll go into here in our algorithm. I have created one package here, algorithm. So I will call it binary search. Binary search. Okay, in binary search here, I will save this number and let me delete all of this. Let me delete all of this. So let's first write for binary search and then we will see the linear search. So here I will create one function. I will call it binary search. Binary search, and what I have to pass like number list and number to find, and let me create this. Create is fine, and here meantime what I will do, like maybe I can create one if name name what we call it, equal to main, right? How we write it like this only, yeah, main like this and like this. So if I run it, is it working? Yeah. So this is what you have to do. You have to reformat it. Now you are calling this binary search. We got the binary list number to find. So first thing what we need to do, we will declare three things here. First thing we'll say left index. Left index we will always start with 0. Right index we will say length of numbers numbers list, and then minus 1 you got, and then we will get mid index. What you gonna get, you have to basically say left index plus right index, and you have to do a division with 2, gonna get 3. Now mid number you have to get, as I explained, right? Mid number how we'll get, we will get numbers list, and you will pass the mid index. Now you got the mid number. So first condition that you're gonna put here is if your you got the mid number, right? Mid number equal to number to find, number to find, then you're gonna return the index. Return the index. What index you will return? So you will return the mid index. Okay, mid index. So you got the mid number matching, right? Now another condition you have to write, if mid number mid number is less than, now what we are checking is mid number is less than number to find. So mid number if less than yeah, mid number is less than number to find. So in that case, and this whole thing I have to do inside, like let me do it. So we have to put here is a while loop, while left index is less than equal to right index. So here you just put these things here, and then you can start doing this. So this is what you got, and this is where you got mid index, and then you got mid number. And if your mid number is less than, so in this case, what is the mid number? Mid number is 29 for our example. Mid number is less than number to find 21. So in this case, now what we need to do here is we have to update the left index here, mid index plus 1. This is what you need to do. And number is greater than if mid number is greater than number to find, in this case you have to update the right index. Here you have to say mid index minus 1. This is what you need to do. And finally, if so, this is what you have been doing. And every time now you go, and since we are updating left index, right index, and we are iterating through loop, so every time if you do not meet the condition, you're gonna get left index updated, right index updated. You will iterate through the same process. So finally what you will do, so I mean, at the last you're gonna meet this condition if element is present that you are searching for. If not, then finally you can return minus 1. Okay, so this is what is the condition. Let me little format it and let me see. Okay, I'm not printing something, so here I can say index, and I will say print f. Here I will say the given element is present at index. Okay, now if you run it, what happened? Not getting return 1, return mid index. Okay, so index. Okay, I think some problem. Let me remove it. I think this is causing problem. I'm missing this one, so that's why it's like not running the program properly. Now you got this, right? So here, if you see what's happening now, int and list, where which line number, if mid number. Okay, here I think I put it wrong, not number list, but number to find. So you see, like now this time you should be getting the index 4. So if you've seen the list, so this is zeroth, this is 1, this is 2, this is 3, and this is 4. So 21 you got, and the index is 4. Index is 4. So this is binary search, right? Let us write linear search also. So here I will go and write a linear search. Def linear search. Linear search you got, and here similar as like the same parameters, just copy here, and this is going to be a very simple solution, guys. So here you just need to iterate through a loop, like for element, I will say in numbers numbers list, number list. So simple, very simple. And guys, when you trade trick, so we have to get also the index. So you can do one thing. You can just add a enumerate function and can pass the list. So in this case, it will give element as well as the index also. So here I can say index and element. So here I would call if element equal to number to find, then return what index. Otherwise, you come here and return -1. So call let's test this out, and I will reformat it. So similar as this, again I will pass the same. Here I will say linear search, and linear search I think I have. Okay, it's linear search, and here I will say linear search index, and here I will say binary search linear search index, binary search index. So here I will say binary search index, and then you have to say a linear search index, guys. Okay, let's see what the output we are getting. So in the both the cases we are getting 4. So our solution is working, guys. So one thing that you can see, if you can measure the time taken by this two approaches, you'll find that linear search is taking more time because it's gonna take search through each element and then finally find 21. But this binary search is basically discarding half of the search because it's comparing the middle element, gets sorted, and if it's finding element is greater than the middle element, then it's going right side. If it is less, then it's going left side. So we got the working solution. So guys, I will also try to write binary search function using the recursion. Here you say we are using like while loop, but now we're gonna use recursive search, sir. Okay, well, I mean, write binary search in a way it will use the recursion. Okay, so I will call it binary search recursive, guys. Okay, and here you got number to find. I would require here two extra arguments. I will say here left index and the right index. Okay, and here I mean just don't do anything. So this is still require, I mean, this thing. So let me put all of this in a similar way, and finally I will say return recursive binary search, and here I will say numbers list, number to find, and then left index and right index. And here you need to do one thing, guys. If you find uh yeah, so we got the mid index, right? Once you got the mid index, just do one thing. Mid index, or yeah, mid index. So if mid index is greater than right index, or like this, not right index, but you can call it, yeah, length of, yeah, I think right index. If it is greater than right index and mid index is less than 0, so in this case, what you're gonna do, you're gonna return -1. So this is one condition. I mean, your mid index, if it is greater than right index, so that is a wrong case. That can never be a case. And also another condition, if mid index is greater than 0, that is also a not a valid case. So guys, just a small change here. Instead of saying right index, because the right index can change in our iterations, we will say length of what? Numbers list. Okay, length of numbers list, and this is fine. And another condition that we can also add here is key, if right index is less than left index, then also you need to do return -1. So this is another condition. Let's do also call this function. So I will say binary search recursive index, binary search recursive index, and here you can pass numbers list you are already passing. 0 you can pass as left index you can pass 0, right index, right GHT right index you can pass length of what? Length of um numbers list -1. So this will be your this thing. So I think this would work. Let me also add a print here, and not a binary search. We're gonna get binary search index, binary search recursive index. So here I will say binary search recursive index and the element percentage index. Okay. So let's see what it returns. We are getting some error. Let's see. Linear search got an unexpected keyword argument left index. Where we are saying this. Oh, okay. No, 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 no. Actually, I have to not linear search, but it's a binary search. We put a wrong function name. It should be fine now. It should be fine now. You see, all are giving 4. And here you see binary search, linear search. So guys, this is the explanation. So you saw the hands-on working code. Very simple algorithm is you will find for binary search and even for linear search. And you saw binary search we wrote in a using a while loop, another using a recursion, and then linear search is very straight approach, straight can be solved. So I hope you are clear, and if you like the video, please hit the like and share with your friends. If you are new to the channel, please subscribe my channel. Thank you so much. See you in the next video. Bye.